What's good, team? Welcome to another Small James coding tutorial where today we're going to be building a Dockerized backend. We're going to be building it with Postgres, Node.js, and Express. So it's going to be good for all types of CRUD applications. We've got our database, we've got our service, and it's all in one Dockerized environment, 2 different containers. We're going to be looking at how we can use a compose.yaml file to start it up with one command so that you can start sending network requests to it and go build out a full stack application with it today. So if you enjoy the video, don't forget to like and sub, and let's dive into it. The first thing we're going to do is start off inside of a terminal here, and we're going to make a directory, and I'm going to call this docker compose example. Now if we cd into docker compose example, we can open that up inside of a Visual Studio Code editor. So here we have our editor just here, and in this directory we can create a couple of files, but we're actually going to do the first one from the terminal, and that is going to be npm init-y. Now the prereqs for this tutorial is that you're a little bit familiar with Node. Obviously for this tutorial you will need Docker installed on your computer, so make sure you have that done in the background. You'll also want the daemon running. You can see that mine is running up here. And now that we have this npm init file, we can go ahead and install Express in addition to another package called PG. So PG is for Postgres. So now if we come into our package.json file, we can see that we have these 2 dependencies installed, and we can just go ahead and add a development script. So inside the script tag here, and that's just going to say node server.js. So this command will boot up our server. We're obviously going to need a server.js file, and while we are at it, we will also need a database.javascript file. So now that we have some of these files set up, the first one we're going to work with is this database file. And so in here, what we're going to do is we're going to say const pool is equal to, and we're going to require PG. PG is obviously our Postgres interaction package for Node.js. And so in here, what we're going to do is we're going to say const pool is equal to new pool, and that is my bad. This one up here is meant to be capitalized, so they're not the same. And we're going to call pool as a method, and inside of it we're going to pass an object as an argument, and this object is going to have a couple of parameters. The first one will be host, and we're just going to call that database. After that, we're going to provide a port that it's going to start up on, so we're going to give it 5432. We'll give it a user. You can name it whatever user you like. I'm just going to go user123. We will need a password. Once again, this is up to you. I'm just going to once again go password123. And finally, we're going to have a database, and this is just going to be db123, so inconsistency. Now, it's good to keep these accessible now because we'll need them when we set up our compose.yaml file, which will come later. But the final thing we'll do in this file for the minute is we're just going to go module.exports is equal to pool. Now this export is going to allow us to require this into our main server file. So if we go ahead and start up our server, the first thing we're going to do is require Express. So this is the Express server package for Node.js. After that, we're going to const pool is equal to require, and we're going to require that from our database file. So now we can access our Postgres database essentially and call methods on it. And then the last one is const port, and that's just going to be 1337. Now what we can do is we can say const app is equal to that and call Express as a method. Now this will initialize our server app with Express. And then finally at the bottom, we're going to say app.listen, and we'll pass in our port and a callback function that just says console.log template literal string server has started on port, and pass in our port as we always do. So just like that, we have initialized our file. Now we can come in here and we're going to set up 3 routes within our server. The first one is going to be a get route, and that's just going to be at our home path. Then we'll take request response, open that up as a callback function, and in here what we're going to do to just test that it's working is we're going to send status 200. And we can now test this first by running npm run dev. We can see that our server has indeed started on port 1337, and we can emulate a network request using a test.rest file. Now these test.rest files are equivalent to using a service like Postman, and to preface this, you will need the REST client installed inside your Visual Studio Code. So here you can just install this extension, And now you'll be able to use these REST files, and essentially it's so easy. You just type get, type in the URL just like that. So it's just get, and then the URL will separate it from another request using 3 pounds. And now we can send that request, and we can see that we did in fact get a 200 response from our Express server, and that is exactly how it should be. So now our server is working perfectly. The next thing we can do is add 2 more. So what I'll just do in here is call these the routes. Under here, we're going to have to say app.use express.json. So this is going to allow our server to receive JSON data, which is going to be very important for this. And consequently, we can define a post route that's also just going to be at the home path. You can have whatever path you like. We'll do request response, open that up, and we'll just say const name and location, for example. Those are the parameters we're going to be needing, and we will access them from the body of the request. Now, I should mention at this point, if you aren't 100% familiar with Node.js, check out the Node.js crash course I have on my channel. But anyway, let's continue. So we're going to access this information from the body, and what we could do in here is just say res.status 200.send, and we can just send back a message that says your keys were, and then we can just pass in the name and the location inside of a template literal string. And now we can go ahead and test this route, keeping in mind that we have name and location. We can define a post route, say http://localhost1337, come down onto a new line for post requests. You'll have to specify the content type as application/JSON, and then we will actually pass in the JSON. So here we have the name that is going to have a value of, let's just say James. Then on a new line, we will have the location, and we will just say some random address, 23 Hello World Street. So if I send this request, our server is still going. We should hit this post route, destructure that information, and then send it back in the form of a string. Let's go ahead and test that out. And we can see that that doesn't work because we just have to remember to restart our server so that these server changes are updated since we added the post route. And now that we've restarted it, if we send that request, we can see that we do in fact get back a successful response. So our server is working with our 2 routes. For this tutorial, we're just going to do one more, and that's going to be at the setup path. It's going to be a get route. And in here, what we're going to do is just open up a function call here. And in this one, we're actually going to start interacting with our database. So we're going to have a try and a catch block where we take an error. In here, if we get an error, we want to console.log the error, and we want to res.send status 500 to show that something has gone wrong. The other thing we're going to have to do to interact with our database using pool is we're going to have to make all of these functions, these callback functions, asynchronous. So now that that is an asynchronous function, we're going to call our first Postgres method. And the way that we set that up is by typing await inside of our try block, pool.query, and inside of query, we can run our SQL commands. Now, if you're not so familiar with SQL commands, you can find virtually everything you need to know about them at this w3schools.com. They have all the different commands you could need. We're just going to be focusing on some basic CRUD functionalities, such as like update, delete, select, and creating tables. For example, creating a database. Make sure to check these docs out, linked in the description down below. So anyway, let's continue with our first command. And here what we're going to do is we're going to type create table schools. So it's going to be, and once again, this is SQL terminology. You can see here that this is the syntax that we're using. So it's table name, then column type, then data type. So we're going to create the schools. And inside here, we're going to have the first column, which is going to be the ID, and this is going to be serial primary key. So once again, this information here is just the data types and some extra special little parameters. We're going to separate our second column by a comma, and that is going to be name, and so that's going to be the student name, and this is going to have a type of variable character with up to 100 characters. And then the last one is going to be the address, so that could be their home address, and this is going to be a school database. So now that we have the address, once again, that's going to be separated by a comma, and that's going to be a variable character and another 100. So this is going to create our table, And now that we have the command for creating our table, the next thing we're going to do is actually come into our post method and make these a bit more specific. So once again, we're going to do this inside of a try catch block. We could actually go ahead and copy that logic across. We're going to have to make this an asynchronous function, and likewise with this one, because these are our 3 routes. And in here, this query is instead going to be an insert command. So how that's going to work is we're going to type insert into school. So we select the table name. We're going to use we're going to use the circular parentheses to select the column names that we're going to be inserting into. So that's going to be name and address, just like we made them down here. We don't have to worry about the ID column because that will be automatically created for us. And then we can pass the values command. And in here, we're just going to provide a temporary placeholder of 1 and 2. And the way that the database package works is you can pass in arguments in an array inside. So the second argument to this query is essentially an array that contains the arguments that will fill these placeholders. So 1 is going to be associated with name, and so we're going to pass in the name, which is just going to be there. And the second one is obviously going to be the location. So that should do well for this command. We will then res.status send back a status of 200 successful, and we'll send back maybe a message. So we could pass in a message here and just say successfully added child. We also actually want to copy this and send back a status on the setup one as well. So the message could be successfully created table. Now that's a fair amount of our CRUD functionality done. We create a table we can insert into our table. The last thing we want to do is, read our entire table. So we're once again going to copy this try catch block and paste it inside of our get route. This get route is just going to return the entire table back to us. And so this one's going to be slightly different because we're going to need to assign the data that we fetch to a variable that we can then send back to the user. And instead of all of this stuff, we're just going to use a basic select command. So select asterisk means all from schools. So we select the table. Once again, that's just this command right here. And now what we could send back, is we could send back some data that's just children. And instead of sending back a message, we can send data.rows. So we can access the rows of our table, and that will contain them in the form of an object, just like that. Honestly, you could be even more efficient and just pass back data.rows because that will be an object. So that's going to be our whole server. We're not actually going to test the server just yet because we're going to start it up inside of a Dockerized environment. So once again, this is the step where you will need Docker to be running in the background. And we're going to kick this process off by creating a Docker file just here. And this is going to be to set up our entire node environment. So the way Docker files essentially work is they create an environment that is going to be, the same on anyone's device. So just in the same way that I run my Node.js server on my device here, I'm going to create a mini environment, which is kind of like a virtual computer that's going to do the exact same things. However, I just have to set up this environment before I go ahead and run my server. So the first thing we're going to do is we're going to pull a package, Node version 16. And what that's going to do is it's going to pull Node, and it's semi-equivalent to us installing Node onto our device. Then what we're going to do is set up the work directory path, and this one is going to be user/source/app. So what the work directory command does is it's used to define the working directory of a Docker container at any given time. And then basically any following run command, add copy, or entry point command will be executed in this specific working directory. After that, what we're going to do is use a copy command, and we're going to copy from our local folder, so this local folder here, into this working directory inside of our Docker container. And we're going to copy the package and any extension of package. That's why we have the asterisk there, so it will take the package lock file as well. We're going to copy it from this local file so we can access that directory. And then we're going to pass in a to route. And so instead of doing everything again like this, you could technically specify this route, but equally what we can do is just paste it in the current working directory inside of our Docker container. Then what we're going to do is npm install. We're going to run that command inside of our Docker container. So that will install all of the dependencies inside of this package.json file that we have copied. And that will create a node modules file inside of our Docker container. And then what we're going to do is do another copy. And essentially what we're going to do, and I acknowledge this looks a bit cryptic, is we're going to copy everything from our source folder. So that's all of this stuff here, our server, our test.res, our database.javascript configuration file, all of this stuff from our directory here into the source directory of our, or the working directory of our Docker container. So now all of this stuff gets copied over. It's essentially creating a new folder and pulling all of this information over using Docker commands. And then the last thing we're going to do is expose our port, which is going to be 1337. And so what this command does is this exposes the internal port inside of the container and exposes it to the, the rest of our local host or the rest of our local machine. And now that that is exposed, we can run a command line or executable. And in this case, it's just going to be a sentence. So a sentence is basically split up into each of its individual words. So it's going to be npm run dev, and this is just this development script that we created inside of our Docker file. Now what we're actually going to do is just quickly change this port to 3000 so that we can experience what port mapping is, and we're also going to change this to 3000. So inside of our Docker container, that's going to open this up on port 3000. However, externally we're going to access it from 1337, and that's basically on our local device. So that's the Docker file done. Just once again to summarize the steps, we pull the download that we need to run Node, we create or set the working directory, we copy across our package.json file from our local folder into our Docker container, then we run npm install inside of our Docker container, then we copy everything from our current folder into our working directory of our Docker container. We expose the port that we're going to access it on, and then we basically execute this command, which is npm run dev, and start up our server inside of the Docker container. So it's just a recipe, a set of instructions. And now that we've done that, we can come across here and create a docker compose.yaml file. And this is going to allow us to run docker compose up, which is an excellent command, and it saves you from having to execute all of these Docker containers independently. And the way that this is going to work, we're going to first set the version, and that should actually be just like that. And then we're going to set services, and this is where the important information is. So services is going to want to be tabbed across just once. And the first service we're going to have is our database service. So this is essentially going to be an independent container. We don't have to create a Docker file for this because we can just pull an image directly from the internet, and that's going to be the Postgres image. So we don't have to do all of this copying stuff with our Postgres database. We can just click run. So instead of creating a custom Docker file, we can essentially just use the internet's Docker file for it or pull that image directly. When you create a Docker file, you have to build it, which images that Docker file itself. So it's slightly different. But anyway, since we don't need all the configuration for our Postgres database, we can just image it directly and not have to worry about a Docker file for it. After that, we have to set up the environment for it. And the first thing we're going to have in here is a Postgres password. And this is going to be password 123. And you'll want this to match up with the information that you have inside of this database.js file. So if we carry on, the next one is going to be Postgres user, and that is going to be user 123, and then we're going to have Postgres database, and that is going to be db123. So that is that environment, and then we're going to set up a second container, which is going to be our app, and our app is going to run our Node.js server, our Express server. So in here, all we're going to do is pull the image from my app. Now this doesn't currently exist, and I might make this more explicit, my Node app. And after that, we're going to do some port mapping. And essentially how the port mapping is going to work is we're going to do dash, and we're going to set 1300 as equivalent to 3000. Now we exposed port 3000 for our server that is inside of our Docker container. If we want to access that from our local device, we have to map it across to a port that is essentially on the outside of that Docker container, so on our local device. So now if we send a network request to localhost 1300, that gets mapped across to localhost 3000 inside of our Docker container, and consequently to our server.javascript file. Now for this image here, we're going to have to build this image. And the way that we build the image is we type docker build -t, and then we give it a name. So it's going to have to match up there. So my node app. And then finally we do a source. And so that's just a plain bullet point. Now if we run that, we can see that Docker is building this image, running all of these commands. We can see the order in which the commands are being run. And now that that is all finished, we can see that it wrote this image, it exported the layers, it compressed them into an image, it gave the image a name, and that is accessible within our Docker basically environment. And we can check that that worked by typing Docker images. And that's going to bring up a list of all of the Docker images you've ever worked on. And we can see at the top here, we have my node app, the size, when it was created, all that good stuff. So now that's going to be accessible for our compose.yaml file. And so we can save that. And now we can go ahead and compose this and boot it all up by writing docker compose up. That's going to look for this compose YAML file. And we can see that that is meant to be ports, not ports, so that's my bad. We're going to run that again, docker compose up. It's going to use our Docker environment that's running in the background. It's executing all of our containers. You should be able to see it inside of your Docker daemon if you open that up. And we can see that we actually got an error code here which just says npm is not found. What we're going to do is just quickly run docker system prune to clear all of our Docker environments currently and just make sure that we rebuild this. So this is going to be docker build -t my node app, and then pass in the source environment. That's once again going to build our whole thing. We can see that that was super quick. We can go ahead and run docker compose up once more. And we are just looking at the logs. We're still getting an issue that says npm run dev, that script is not found. And I think the problem here is actually that it's single quotations. So it's just going to be npm space run space dev. And that's got rid of that error. So you just want to make sure that you are not using single quotations inside of your Docker file. So if we once again run docker system prune, we can make sure that we don't get any caching of our images. We can see that we have deleted that image. We can go ahead and run our build command once more, docker build -t my node app, pass in the source directory. That is all done. We can now go ahead and run docker compose up. That's going to execute this command. Everything is working well. It's created our containers successfully. And now we can see that at the very bottom, our server has indeed started on port 3000. We get that console. However, now it comes from within our Docker containers. And our server is fully started. Our Postgres database is up. Our database system is ready to accept connections. So what we can do is once again come back in here, except now this port is going to be 1300 as we defined inside of our Docker, our port mapping. We can change both of these to 1300. Now what we're going to have to do is come into our server. We're going to have to first run this setup command. This is a bit of an unconventional way that you would set up a Docker container running a network request, but it's, these CRUD ones are better representations. However, for this, it's convenient. So we are going to make another get route. So we'll just separate them with the triple pound. And here we'll say get http://localhost 1300/setup. That's a GET request. We should be able to run this. We can see that we get a 200 response back. We get a message that says we have successfully created our table. So that is super cool. Now what we can do is we could run the GET request. That will get us back all of the entries in our database, so there's none. And then we can go ahead and add entries to our request. We successfully added the child. If we run the GET request again, we have our first entry. I could change that to say Lucy, and she could be at 46. Hello Street World. We can run that again, successfully added the child, get that once more, and now we have 2 entries inside of our Dockerized database, Postgres database. Anyway, that's pretty much the whole video. Once again, we just Dockerized a backend application with a database and a server. Super convenient. We looked at how we can send network requests, map ports from within the container to outside the container, and run it all with a Docker Compose. If you enjoyed the video, don't forget to like and sub. Super appreciated. Thank you so much for watching, and I'll catch you guys in the next one. Peace.